Hey, what's up, YouTube fans? So what I wanted to talk about in this video, right, is the evolution of land vertebrates from fish, right? All land vertebrates, including ultimately us humans, right? So us humans, we're actually descended from fish that existed hundreds of millions of years ago, literal fish that were our ancestors, right? And this is one of those major macroevolutionary transitions that will, to some people, seem implausible. Some of the types of people that say that they believe in microevolution, but not macroevolution, they'll say things like, oh, I could see how fish could adapt, as fish adapt over time, that they could become better at doing things that fish do, like swimming, but how could they ever adapt to life on land? Well, so it actually is not as confusing as it could seem at first glance. It's not as confusing to understand. What you're first going to want to understand, if you're trying to understand how this works, right, is that the earliest land vertebrates were not humans, right? They were much more like salamanders, right? So it's not like transitioning directly from a fish to a human. That would obviously be impossible, right? So humans are many steps down the way. Instead, it's transitioning towards something more like a salamander. And then from that species comes all tetrapod species alive today, right? Eventually, right? So all species of amphibian, bird, and mammal branched off from the earliest tetrapods, right? Which evolved things such as carpals and metacarpals and tarsals and metatarsals and phalanges and eyelids that blink, and having their ribs form a cage with a sternum, and having their pelvis more adapted to land, right, with 3 pelvis bones. There's a lot of unique adaptations that were evolved when tetrapods transitioned to land, and then all modern tetrapods inherited these features, right? But the evolution of humans is still many steps down the way. Even the evolution of mammals is, right? So that's the first thing that's important to understand, is that it's not directly a transition to human, right? It's a transition more to something like a salamander. And then what's also important to understand is that even alive today, there are some fish that go on land, right? So mud skippers are an example of a group of fish that actually spends more time on land than in water. They have the ability to move around on land and to breathe on land and spend extended periods of time on land. And then also the also the lungfish, which DNA evidence indicates are the closest living relatives of tetrapods. They have actual lungs, which is why they're called lungfish. So even though they're fish, they have lungs and gills, and they have the ability to move around on land, spend extended periods of time on land. They do spend extended periods of time on land. And they have 4 primitive limbs, right, with a similar bone pattern to the limbs of tetrapods, whereas 1 big bone, 2 smaller bones. Some of their fins are already modified into primitive limbs, and this isn't even fossil creatures. They're alive today. You could see videos of them moving around on land, right? So it's not just like something long ago. It's in the present. We see creatures like this, and DNA evidence indicates they're the closest living relatives of tetrapods. So that's the biggest thing. That's one of the biggest things to understand, that, even though people will often have this impression that, fish never leave the water, they're all strictly in the water, that's actually a false impression. There are fish that can spend extended periods of time on land. So then that really erases away the illusion of this impassable barrier between water and land, right? And yet, even though they're capable of moving around on land, they still lack many of the adaptations that tetrapods have, showing that you don't need to have all of those in order to start moving on land, right? And then furthermore, we have intermediate fossils for the evolution of tetrapods, right? Fossils such as Tiktaalik, right? Which is, it's not just a single fossil, it's species with many fossils that have been found for it, right? And they were fish with necks. Radiometric dating indicates that they showed up before any actual tetrapods, right? As did fish in general, but also fish in general showed up long before Tiktaalik, right? And so all of the earliest vertebrates that show up in the fossil record are fish. That's how it is for hundreds of millions of years before we get any other vertebrates in the fossil record, which is part of the evidence towards tetrapods having evolved from fish, right? And so once you understand that, some fish spend extended periods of time on land, so moving on land is an activity that some fish do, then it's a lot more of a straightforward process, because if they're already spending extended periods of time on land, then as they adapt over time, they're likely going to adapt to life on land, right? More and more, right, over millions of years. And then remembering that the earliest tetrapods, they were not humans, they were not walking around bipedally on 2 feet like us, right? Or even, they weren't even walking around in as complex of a way as a dog does, because they were not only walking quadrupedally, but their legs would have been coming out of the sides of their body, more so crawling across the floor, right? Similar to salamanders and lizards, right? So not even as advanced of a form of movement as a dog has, let alone humans. And in fact, the earliest tetrapods were more primitive in their movement than modern tetrapods, right? And also the fossil record indicates that the earliest tetrapods generally have more than 5 toes per foot, right? Whereas modern tetrapods have 5 or less, generally have 5 or less digits, right? But then eventually the pattern of 5 was settled upon, and some groups have gone to less than 5, right? But very few have ever since then gone back to more than 5. And so a perfect example of how what could seem as like an impassable evolutionary barrier, right? When you like look at things in the big picture, right, you see that, it's actually a lot more straightforward than it would seem at first. And so it doesn't require invoking like anything beyond the regular evolutionary processes that we're used to, right? Such as natural selection, mutation. It's not involving like any type of like magical process that's never been observed. It's relatively straightforward when you understand that, moving around on land for long stretches of time, that's actually a thing that some fish alive today do, right? And then you could talk about how do those fish even begin to be able to do that. But I mean, that's a lot simpler, right? Because they're not as well adapted to life on land as tetrapods, right? And their fins are just basically more so adapted to life on land, right? Fins are a thing that already all fish have, right? but their fins are just more so adapted towards moving on land, whereas for most fish, it more so is used for moving around in the water, right? So there's gradients, right, that many people will not see at first glance, right? All right, that's all for now. See you guys.